Every single day we rely on this powerful, invisible force to run basically everything in our lives. But what happens when that power decides to go off script? Well, it can get incredibly dangerous fast. So today, we're going to pull back the curtain and look at the unseen guardians living in your walls, the ones that keep you safe when electricity goes rogue. Just think about it for a second. Electricity is kind of like water. It's always looking for the easiest path to get where it's going, the path of least resistance, right? And when it finds a shortcut that we didn't plan for, well, things can go from perfectly normal to an absolute disaster in a heartbeat. So what actually happens when it breaks the rules? You get a condition called overcurrent. And put simply, it's any amount of electrical current that's higher than what your wires or your devices are built to handle. All that extra energy has to go somewhere, and where it goes is into heat. A lot of heat. This heat is the real villain here, and it's more than capable of melting the plastic off of wires and starting a fire before you even smell smoke. Okay, so overcurrent is the big bad. But like any good villain, it doesn't just have one move. It's got a couple of different ways it can attack. So to really appreciate how our homes defend themselves, we first need to understand exactly what we're up against. So let's meet the two main troublemakers, the overload and the short circuit. Now, they both cause that dangerous overcurrent we talked about, but they could not be more different. One is like a slow, creeping burn, while the other is like an instant explosion. And trust me, knowing the difference is the key to understanding how we stop them. This chart really lays it all out. On one side, you have an overload. This happens when you ask a totally healthy circuit to do way too much work. Like plugging in the microwave, the coffee maker, and the toaster into one outlet. The current gets a bit too high and the wires start to heat up slowly. The danger is a gradual fire risk over time. But a short circuit? Man, that is a whole different beast. This is a catastrophic failure. Imagine two bare wires with power in them actually touch each other. The resistance drops to almost zero, and the current skyrockets to insane levels instantly. We're not talking about a slow burn here. We're talking about an immediate violent flash of heat that can vaporize metal. It's a huge fire hazard, right now. So how in the world do we stop these things? Well, our first line of defense is all about protecting our stuff. The wiring inside our walls and all the expensive things we plug into them. So let's meet these frontline guardians. In pretty much any modern home, your number one soldier is the miniature circuit breaker, or MCB. I want you to think of it like a tiny, super vigilant guard that's always on duty, just watching the flow of electricity. It has one simple mission. The second it senses a dangerous surge, it slams the door shut on the power. Click, job done. And this is where the MCB is just so clever. It basically has a two-part brain to fight both of our villains. For those slow-building overloads, it has a thermal trip. Inside, there's this little strip made of two different metals stuck together. As the circuit overheats, the strip gets warm. And since the two metals expand at different rates, it starts to bend until it bends far enough to physically trip the switch. But for the sudden, explosive violence of a short circuit, that needs a much faster response. So a massive rush of current creates an instant, powerful magnetic field that yanks the switch open in a fraction of a second. It's two totally different solutions packed into one elegant little device. Of course, before we had circuit breakers, we had fuses. These are the original guardians, and they are beautiful in their simplicity. A fuse is really just a special, thin piece of wire that's designed to be the weakest link in the whole circuit. When there's an overcurrent, that little wire heats up and melts, breaking the circuit. It's simple, it's effective, but it is a one-time sacrifice. Once it blows, it's done its job, and you have to replace it. Now, protecting our equipment from fires is obviously super important, but it's really only half the story. There's something else, something way more precious that we need to protect. Us, people. And for that job, we need a completely different kind of guardian, one with a much, much more sensitive set of skills. Okay, I need you to lock this number into your brain. 30 milliamps. That's 30 thousandths of an amp. It's a tiny, tiny amount of electricity, but it's enough to mess with the electrical signals that control your heart. It can paralyze your muscles, stop your breathing. It can be a lethal dose. Now, let's look at the number on a typical circuit breaker in your house. 20 amps. That's 20,000 milliamps. Do you see the problem here? There is a massive, terrifying gap. A standard circuit breaker won't even notice the tiny 30 milliamp current that could be fatal to a person. It's designed to stop a tidal wave. It's completely blind to a deadly trickle. And this really hammers home the single most important takeaway here. Your standard circuit breakers, your fuses, they are not your personal bodyguards. They are fire marshals. Their job is to prevent the huge surges of current that can burn a building down. They are completely 100% blind to the small, precise currents that can stop a human heart. For that, you need a specialist. And that specialist is the residual current device, or RCD. Its entire reason for existing is to do the one thing an MCB can't: detect those tiny, dangerous trickles of current that means someone is getting an electric shock, and shut the power down now. And the way it works is pure genius. Think of it like a super meticulous accountant to your electricity. It is constantly measuring the current going out on the live wire, and at the exact same time, it's measuring the current coming back on the neutral wire. In a healthy circuit, those two numbers should be a perfect match. What goes out must come back. But if even a tiny amount of that current goes missing, say by leaking through your body to the ground, the RCD sees the imbalance in the books and instantly shuts the whole operation down in just a few milliseconds. It's unbelievably fast. Now, all of these amazing devices, the MCBs and the RCDs, they rely on one foundational system: grounding, or sometimes called earthing. This is the ultimate safety net. It's basically a third wire that connects all the metal cases of your appliances and your whole electrical system safely to the actual earth. So if a wire comes loose inside and touches a metal casing, the grounding gives that dangerous electricity a safe, easy path to flow away, which prevents you from getting a shock and helps the breakers do their job properly. So you see, it's not about any one single device. It's about how they all work together as a team in a layered defense system. Each one is guarding against a very specific kind of threat. So let's put it all together and see what this complete shield of safety looks like. So think of it as a three-layered shield. Layer 1 is all about protecting your property. You've got the heavy hitters, the MCBs and fuses, and they're there to stop the big, powerful surges that cause fires. Then you have Layer 2, the more sensitive layer, and that's all about protecting you. These are the RCDs, your personal bodyguards, constantly watching for those tiny currents that signal a dangerous shock. And holding it all together, the foundation, is Layer 3, grounding. That's the universal escape route that makes sure any stray electricity goes harmlessly into the earth, instead into you. So that brings us to the final question, and this one's for you. These guardians are on the job, protecting you 24/7. But when was the last time you checked on them? A simple push of that little test button on your RCDs, or a periodic checkup from a professional electrician, that's not just routine maintenance. That's making sure your guardians are awake, alert, and ready to save a life. And that life could very well be your own.